Hello and welcome back, future scientists. In this video, I'm going to do a tutorial for grade 12 chemistry. We're going to solve a problem involving heat and physical changes of a substance, which is going to involve both increasing the temperature of that substance and changing its state. Let's get started. So here's the question we're going to try and answer. How much energy is required to raise the temperature of 0.5 kilograms of water from negative 20 degrees to 80 degrees? And this is going to involve a couple different calculations. First, we're starting all the way down here, where water is a solid at negative 20 degrees. And then we're going to rise all the way up to 0 degrees. We're going to need to calculate the heat required to do that. Step 2, we need to take that ice and melt it. So we have a phase change or a change of state. We're going to need to calculate the heat to do that. And finally, to go from 0 to, 80? From 0 degrees to 80 degrees as liquid water, we need to figure out the energy to do that. Then we're going to add them all together. So let's start with minus 20 to 0. To do that, we're going to use this equation. Q, which is our heat, is mc delta T, where m stands for mass, and C stands for our specific heat capacity that you're going to have to look up. For water, it's 4.18 joules per gram degrees Celsius, which means it takes 4.18 joules to change 1 gram of water by 1 degree Celsius. And then delta T is our temperature change in Celsius. So let's figure out what this would be. Let's call this Q1. So we're going from, this is minus 20 degrees to 0 degrees as a solid. So Q1 equals mc delta T. So the mass in the question was 0.5 kilograms. C, I said, was 4.18, but that is actually for liquid water. It's going to be different depending upon the state. And for a solid water, or ice, it is actually 2.01 joules per gram degrees Celsius. And then our temperature change, we're going from minus 20 to 0. So change is always going to be final minus initial. So this is our final, so 0, minus our initial, which was negative 20. Now here you can see Celsius will cancel out here. Okay, but grams won't cancel out with kilograms. So to make sure everything works, let's multiply this by 1,000 to 500 grams. So now grams cancel, and we'll be left with joules. When we plug that into our calculator, we get around 20,100 joules, or 2.01 times 10 to the 4 joules. If you like, you can divide that by 1,000 and get 20.1 kilojoules. All right, so that's how much energy it takes to go from minus 20 degrees to 0. Let's move on. Now that we've brought it from minus 20 to 0, we need to melt it. So change its state from solid to a liquid. To do that, we're going to use this equation for the energy for melting. It's N, which is the number of moles, times our molar heat of fusion. This is another constant you're going to have to look up. It's different for different substances. But for water, it's 6.03 kilojoules for every mole. So that means it takes 6.03 kilojoules to melt 1 mole of water. So let's figure out how much energy it takes to melt 0.5 kilograms of water. So let's call this one Q2. So Q2 is N times molar heat of fusion. I don't actually know N. I know mass, 0.5 kilograms. So we're going to calculate N just to the side here. It's mass over molar mass. So we have 0.5 kilograms, but let's change that into grams again. So 500 grams. And then the molar mass of water, H2O. So use your periodic tables. You can add that up to 18.02 grams per mole. And we get 27.75 moles. So that's how many moles we have. So we can write this in now, 27.75 moles times our molar heat of fusion for water, which is 6.03 kilojoules per mole. So now you can see moles cancel, and our answer is going to be in kilojoules this time, not joules. So we have to be careful with our units. We got 167 kilojoules. So now we've melted it. Now we need to raise its temperature from 0 as liquid water up until 80 degrees. So our question was to go up to 80 degrees. We've got it up to 0 and we've melted it. So we're over here now. Now we need to increase its temperature up to 80. And for that, we're going to use our Q equals mc delta T again. Let's try. All right, so let's call this one Q3, mc delta T. Our mass, 0.5 kilograms, but we're going to use grams, so 500 grams. Times C, it's now liquid water, so we're going to use the specific heat capacity for liquid water, 4.18 joules per gram degree Celsius. And our temperature change for Q3, we are going from 0 degrees to 80 degrees. So final minus initial. So 80 minus 0, well, it's just 80. And when we plug that onto your calculator, we will get 167 kilojoules. That's just a coincidence that it was the same as Q2. So 167 kilojoules. So to find the total energy, Q total, we're just going to take Q1, add to Q2, and add to Q3. When we do that, we take 20.1 plus 167 plus 167, and we get 354.1 kilojoules. All right, so I hope this video has helped you learn how you can solve heat problems for physical changes in grade 12 chemistry. If you have any questions, let me know. And if you're interested in downloading my free course pack for grade 12 physics, you can do that for free in the description. Thanks for watching, and I'll see you next time.